In this video, I'll be covering the carbon fiber layup process. My name is Ashwin Visvesvaran, and I'm in ME110 section 3. So first, we need to understand what a carbon fiber composite is. This is when thin strips of carbon are weaved together in a variety of patterns known as tows. This fabric is then sustained in a resin to support the tows, and then the fabric and resin combination are cured over a mold to then form a shape. The first process is known as the pre-impregnated or pre-preg carbon fiber process. This is when resin is infused into the carbon fiber fabric ahead of time. The pre-preg fabric is then laid onto molds, vacuum sealed, and cured at high temperatures and pressures in equipment known as autoclaves, as seen in the bottom right. This is a highly precise process for creating carbon fiber parts because the resin density and strength properties are controlled by the manufacturer. It can be expensive and prohibitive due to the highly involved impregnation process for the fabric and access to equipment such as autoclaves. The next process is known as the wet layup for carbon fiber. Fibers are placed into a mold and then resin is manually applied using a brush, roller, or spray gun depicted in the top right. The resin quantities need to be manually and carefully measured and applied to the part to maintain strength and minimize weight. Parts are then placed under a vacuum to remove excess resin and minimize air voids, as seen in the bottom right. This process can be pretty affordable as it doesn't require an autoclave or any other equipment or any expensive pre-impregnated fabrics. Some pros and cons of carbon fiber. So pros, they tend to have very high stiffness and strength to weight ratios compared to aluminum or steel or other conventional materials. It has many versatile applications based on the layup schedule or the direction that the fibers are placed and how many layers you use. So they can be made to be very strong, or you can optimize the weight. The parts can also be electrically and thermally conductive. Some cons, so carbon fiber won't plastically yield. When you exceed its ultimate strength, it can often result in instant failure. So that needs to be taken into consideration when designing carbon fiber parts. It can be more expensive than conventional materials. The manufacturing process is time consuming, and this requires additional steps for mold manufacturing before you can create a part. Carbon fiber is often used in the aerospace industry because of the weight savings you can achieve for the same strength as metal. It can be used in the automotive industry, first seen in the racing applications, again, for desirable strength to weight ratios, but is now being seen more often in mass-produced cars to improve efficiency as it's very lightweight. Also used in the military, again, for the same reasons, very lightweight and very strong. But you can see it used in for small components and creating housings for things like missiles. Here are my sources. Thank you.